Hi everyone, my name is Carlos. I'm a web developer based in Brooklyn, New York, and today we're going to look into pseudocode. We're going to see how to use it, how to write it, and we're going to look at an example where we actually use it to solve a coding algorithm.
So what is pseudocode? Well, pseudocode is a simpler version of a programming code in plain English before it is implemented in a specific programming language. Pseudocode is often referred to as a syntactical representation of a program, and it doesn't have a strict syntax since it only represents the way you're thinking. So it should leave very little for the imagination, so it's readable for most people. One of the most important keys to understand about pseudocode is that it's not a programming language. It's actually a learning and reasoning tool used to help programmers understand and write code. So it's language agnostic. It's something that you write that is not an actual code in any programming language, but that if anyone were to read it, it would be very clear to what is happening or what steps are being taken. So what pseudocode actually enables us to do is to grab a simple set of instructions that are written in plain English and eventually translate that into a program that can be executed. Now, there are a few other reasons why we would use pseudocode. For starters, pseudocode abstracts away syntax to let you focus on solving the problem in front of you. So instead of getting bogged down in the exact syntax of a language, pseudocode allows you to work almost in pure programming logic. This way, you don't actually have to know what exact built-in functions a programming language provides. You can simply write down in plain English what it is you're trying to do. So why else use pseudocode? Well, some people can visualize the entire solution to an algorithmic problem in their mind, while others may find it difficult to come up with a solution without having to first write it down somewhere. In general, pseudocode won't do any harm if not any good. It essentially helps us break down large problems into smaller, manageable pieces. Through this, writing pseudocode allows you to think through a problem with some foresight and lets you anticipate important questions before they arise. This is possible because you're breaking down something into multiple steps. Oftentimes, when faced with problems, a common gut reaction is to jump straight into Google, but there are ways of Googling that are helpful and some that are actually counterproductive. So if you turn to Google before thinking, you're not actually thinking like a programmer. So if you don't take time to write pseudocode and think through the details of the project, you'll end up Googling in an inefficient way. You'll end up wasting time. So in the short term, even though you're writing pseudocode might feel like you're taking two steps back to go one step forward, it is actually saving some time and headaches along the way. And breaking things down with pure programming logic and then Googling or researching what you need to look for will essentially help you in becoming a better programmer. So now let's go ahead and see how to actually write pseudocode, and then we'll solve an algorithm together. Now, pseudocode doesn't have a strict systematic way or standard way of being written. So don't think of these as rules, think of these as more as suggestions on how to get started writing pseudocode. So for starters, you may need to capitalize commands that will remain in the actual code. So if you're using if statements, for example, it's important to keep those if statements in capital letters. This makes it easier to create code blocks and actually spot some of the logic. Next step is to actually stick to writing one statement per line. So each statement in your pseudocode should express just one action for the computer. In most cases, if the task list is properly drawn, then each task will correspond to one line of pseudocode. Another really important one is to use indentation. So using white spaces between blocks of text will help keep different components of your pseudocode isolated. And indenting different pieces of each block will indicate that those pieces of pseudocode go under a less indented section. You also want to make sure you're being specific. So everything that is happening in the process must be described completely. Pseudocode statements are close to simple English statements, and it will be very easy for the person who's reading it if you're actually being specific and detailed for each step. Lastly, you want to keep things simple. Don't write pseudocode in a complete programmatic manner. It is necessary to be simple to understand, even for a layman or a client, so don't incorporate too many technical terms and make things overly complex. Okay, so now that we have an idea of how to write pseudocode, let's go ahead and take a look at an algorithm and start writing our own pseudocode and solution with it. So this is a classic interview question and coding challenge that is very popular and you might have seen before. It's called FizzBuzz. So here are the instructions for FizzBuzz. What we're going to do is we're going to write a short program that prints each number from 1 to 20 on a new line. For each multiple of 3, we're going to print fizz instead of the number. For each multiple of 5, we're going to print buzz instead of the number. And for numbers which are multiples of both 3 and 5, we're going to print fizzbuzz instead of the number. Okay, so let's get started. So I'm using Chrome here, and I'm using my DevTools console in order to actually solve the problem. I've also copied and pasted the instructions so it's easy to break down what exactly we're going to be doing. Okay, so first thing I notice is that we're going to be writing a program that produces a set of 20 different values. So this looks like a perfect situation for a for loop. So we know a for loop is written with 3 optional expressions. So the first one will be the initialization expression. So we're going to be setting out the counter to 1. Then we're going to add a condition for the counter to actually break with. And lastly, we're going to add a final expression, which will be the incrementation number. So once we have our for loop created, let's look back at the problem. We have about 4 different conditions we're going to be working with. This means within our for loop, we're going to have 4 different if statements that actually give out different results depending on the number we're on. So once we have our for loop here, let's make sure we're also using indentation. So let's get started with our first conditional. Now, if we want to check if a number is divisible by another number, we can use the remainder operator called modulo. So if we use modulo on a number and it returns 0, which means the remainder is 0, it means that it was actually divisible by that number. And in one of the cases, we're actually checking if a number is divisible by both multiples of 3 and 5. If so, we're going to print fizzbuzz. So in order to make this short and sweet, we can actually just check if it's modulo 15. If its remainder is 0, then that means it's true, and we can just print fizzbuzz from there. So I'm going to keep some of the key commands in capital letters, like my if and mod, and I'm going to use some indentation under my if statement to make sure that there's a code block within that if statement. So for the next conditional, we want to check if the number is divisible by 3. So else if number mod 3 is equal to 0, then we're going to be printing fizz. After that, we want to check if the number is divisible by 5, and we're going to be printing buzz for that one. So you can see I'm basically following the same kind of pattern here. It's not following a strict, rigid syntax, but it kind of keeps the capital letters for the key commands, and I'm keeping indentation to make sure that there's a code block within each statement. And for the last conditional, which indicates that it is not divisible by any of those numbers, 3, 5, or 15, we're simply going to print the number as is. And there you go. That is essentially our pseudocode. So once our pseudocode is completed, it's fairly easy to actually translate this to code if you actually have the steps pretty detailed and laid out for you. So I'm going to scroll this further down a little bit, and I'm actually going to zoom out so we can see pretty much what we're writing here. So let's start out with our for loop here. We know that the for loop will start with the number 1. We'll keep going until it's less than or equal to 20, and we'll be incrementing it by 1. Let's make sure the first if statement is added. So we want to check if I is modulo, and we use a percentage operator for this one, is equal to 0. And if that's true, we're going to actually console log fizz buzz. We'll close that if statement. We'll write the second one. So we want to check if the number is modulo 3 is equal to 0. If so, we're going to console log fizz. Then we want to check if the number is divisible by 5. So I modulo 5 equals 0. We want to print buzz with a capital B. And lastly, we simply have to print the number itself, which is I. We'll close that up, close up the for loop, and here you go. We have the results here. I'll zoom out a little further so you can see. You can see all the numbers that are multiples of 3 are printed out as fizz. All the numbers that are multiples of 5 are buzz. And the numbers that are multiples of 3 and 5, which is 15 only here, is fizz buzz. Now, the more you write pseudocode, the more you'll find a way to write it that makes sense to you specifically. And writing good pseudocode that makes sense to you is simply a matter of practice. So what is some way you can actually practice in your everyday life? So let's take a look at cooking ramen as pseudocode. Well, with cooking ramen, the first thing you would do is open the packet. Then you might fill a pot with water. Then you might bring the water to a boil before putting the ramen in for 5 minutes. Then you'll stir the ramen once every minute. And then after 5 minutes, you drain the water before you actually enjoy it. So you can turn everyday tasks, for example, doing laundry, cooking something else, going out to a store and purchasing coffee, into pseudocode, and this will help you basically write pseudocode in a way that makes more sense to you.
So hopefully this gave you a better understanding on how to write pseudocode and how to use it. Thank you all for watching. Join the conversation by subscribing to this channel or dropping a comment below. And if you want to take your skills to the next level, start learning on Codecademy today.